You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome. Today we're jumping into some really interesting developments, pulling insights from the latest on development, automation, and security.
Yeah, lots happening.
Absolutely. The idea is to cut through the noise, give you the key facts and surprising bits quickly so you're up to speed.
Make you informed fast.
Exactly. Okay, so let's start with something we hear a lot about, WebAssembly, or WASM. What's it really for, beyond maybe speeding up web pages a bit?
Right, WASM. Its real strength, I think, is in creating these high-performance, secure environments that start up incredibly fast.
High performance, secure. Yeah.
Yeah, and think beyond just browsers. It's valuable for plugins, sure, but increasingly for cloud applications and edge computing, too.
Edge compute, right.
It gives you this powerful, portable runtime, almost native speed.
Okay, that makes sense for specific demanding tasks. But, for just general web development, it feels like adoption has been, well, a bit slow. Why is that? Is it just tooling problems, or is WASM fundamentally harder to work with?
That's a really good point. And for a long time, yeah, the biggest hurdles were gaps in the ecosystem. The tooling just wasn't quite there.
Right.
But, and this is where it gets really exciting, recent steps forward, like built-in garbage collection.
Oh, interesting.
And especially the component model. That's a game changer.
Component model, what does that enable?
It basically lets different WASM modules talk to each other easily, like building blocks, to create complex apps.
Ah, okay, so they can operate properly now.
Exactly. And that said, to massively expand where WASM can go, we're talking cloud infrastructure, maybe even parts of operating systems, and potentially securing AI workloads, too. Think fast, secure, portable code running anywhere.
Okay, so WASM is potentially moving from this, like, niche performance booster to maybe a fundamental layer for cloud and AI.
That's the trajectory, yeah. It's becoming much more foundational.
Right. And speaking of AI, it's not just generating cat pictures anymore, is it? It seems to be getting right into the developer's workflow, especially around quality.
Oh, absolutely. AI is making huge waves in test generation specifically.
How does that work in practice?
Well, take something like GitLab Duo using Amazon Q. It can automatically write pretty comprehensive unit tests for you.
Automatically?
Yeah. The benefits are, well, pretty clear. Better code coverage, more consistency across the board.
And less tedious work for developers, I bet.
A lot less manual effort. It analyzes new code, say, during a merge request, and spits out tests. And it's often smart enough to catch edge cases you might miss.
Like having a super diligent testing assistant.
Kind of, yeah. Tireless and focused just on tests.
That's pretty powerful for tightening up the dev cycle. But, even with all this cool new tech, security still feels like sometimes we're chasing ghosts, right? Old bugs pop up again.
It's true. Security is a constant battle. And sometimes the old threats are surprisingly persistent.
Any examples spring to mind?
A really surprising one recently was the Libpng vulnerability. CVE 2014-9495.
Libpng, that sounds familiar but old.
Exactly. It's an integer overflow vulnerability. The shocking part, it was rediscovered 11 years after it was supposedly patched.
11 years? How does that even happen?
Well, it came down to how it handled user-controlled values in a PNG file, things like image width and bit depth. They weren't being validated quite right, so a specially crafted PNG could trigger a heap buffer overflow.
Ouch.
Yeah. It's a stark reminder, You really need to audit Kimming carefully, especially C code with its integer overflow risks. Patched doesn't always mean fixed forever without ongoing scrutiny.
So these old vulnerabilities can just lurk. What does that tell us about how we should approach security now, beyond just bug hunting?
It really highlights that security needs to be dynamic, not static. We need proactive measures.
Like what?
A good example of a modern approach is how HashiCorp Vault handles secrets, like, say, OpenAI API keys, using its dynamic secrets plugin.
Dynamic secrets?
Yeah, instead of having a static API key that just sits there, potentially for ages.
Waiting to be leaked.
Right. This plugin generates short-lived tokens on the fly. They work, and then they automatically expire.
Ah, so the window of exposure is tiny.
Exactly. It drastically reduces the risk if a token does get compromised somehow. It's a much smarter, more robust way to handle sensitive keys today.
That makes a lot of sense. Wow, okay. We've covered quite a bit of ground. From WebAssembly sort of growing up and finding its place
Its expanding role.
to AI jumping directly into the coding process to improve quality, and then these persistent security lessons from old bugs contrasted with new, smarter protection methods like dynamic secrets.
It's a lot of change, definitely. Development, security, automation, they're all evolving fast.
To wrap up then.
Well, maybe just a thought to leave you with. As all this tech keeps accelerating and the tools get, more and more sophisticated, what new kinds of complexity, but also what new opportunities do you see coming down the line for actually managing and securing it all?
Complexity and opportunity. Definitely something to chew on.
Spoken Tech for your ears.